All right, we're going to go ahead and get started. So, thank you again for joining us. This is the Michigan CNI Energy webinar series. We have two more after this, so we're getting close to the end here. This today we're talking about compressed air, and yeah, I'm going to go over today's agenda, and then we're going to pass it off to Joe, and he's going to talk about compressed air and some of the energy savings with that. So, my name's Fred Seiler. I work here at Clear Result. We're putting this webinar on in replacement of our in-person series that we typically have. I'm going to go through our sponsors, some additional educational opportunities. Then we'll go into the presentation and a Q&A session. So just as a reminder, all of our attendees are on mute. So if you have any questions, there should be a chat bar to either the left or the right-hand side of your screen that you can put your questions in, and we'll get to them at the end. And of course, we'll have a recording of this presentation up on the website after this presentation is concluded, and you can always go there and send us any chat messages on the website that you have about the presentation or about any of the presentations, and we'll get back to you. So real quickly, we want to thank our sponsors. Obviously, we typically have this in person, so we're really grateful that our sponsors continue to support us as we shifted this online this year. We have Consumers Energy, Semco's Energy Waste Reduction Program, Efficiency United, UPCO, and DTE. And they've all been really amenable this year in this shift to an online service for the education side. As a reminder, if you attend 2 or more of these webinars, you'll get a 6-piece grill kit. This is just to thank everyone for being a part of this process this year and kind of helping us out as we continue to find our way in this new environment in terms of large scale events and educational events like this. So make sure to attend at least 2, and we'll be sending around a survey at the end of the sessions just to get your contact information and get those out. All right. And with that being said, I'm going to pass it off to Joe. Joe works with GOE Consulting Firm, and he has over 40 years experience in the energy space, and he has a great presentation today about compressed air. Sorry. Take it away, Joe. Pass my screen
Okay.
over to you.
Okay. Sounds good. Okay, show my screen. And just to check, you can see that okay?
Yep, I can.
Okay, perfect. Okay, well, thank you again, everybody, and thank you for going through that. Today's presentation is compressed air system training, saves energy and money. It's really about compressed air. We're going to be going over a bit of that, but also I wanted to concentrate a bit on a little bit of the training and talk about that. So I already went over a little bit about my background, but as he said, I now have a consulting company, but really I spent over 31 years at Ford Motor Company in many different areas, including a powerhouse chief and global energy manager. So I have a lot of experience in manufacturing operations, and I'm a compressed air challenge instructor and have several certifications in energy and energy management, as you can see on the screen. So I just like to go through and so you know who you have presenting and why the person is talking to you. So we're a little bit quickly about Compressed Air Challenge. It's a not-profit organization, and it's really a collaboration of all of these stakeholders, everything from the end users to KGI, distributors, energy consultants, efficiency organizations, Department of Energies and Utilities. And this group got together 20 years ago, and really it has one thing in mind, and that is to provide the end users the knowledge to improve their compressed air system. So why do we care about it? DOE says that in the United States, compressed air systems accounts for $5 billion a year in energy costs. It makes up about 10% of the electricity in North America and accounts for 16% of any motor-driven system. So it's a lot of time called the fourth utility, and it's for good reason. There's a lot spent there. And contrary to popular belief, compressed air is not free. And really, it's very inefficient. So this just illustrates that for getting 1 horsepower of useful work out at the end use, you have to put 7 to 8 horsepower in to begin with. So you've got the losses going from the switch gear, the motor, all of that good stuff, but the real losses are in the system demand and heat of compression. So compressed air compressors are great at heaters. They're not great at going through and compressing air there, so it's very inefficient. There's a lot of losses there, and heat recovery is an option that you can look at. It's also a very costly source, so it can range anywhere from 18 to 32 cents per thousand cubic feet. In the auto industry, where I come from, it could be 10% of a plant's energy electricity cost to up to 40%. Air leaks can be 20 to 30% and as high as 50%. And in Ford plants, when I was the global energy manager, it was costing several hundred thousand to millions of dollars per year, depending on the facility. So a little bit about training. Many times people are saying, for utilities, they'll go through and say, well, we put on training part of our program. It's an education. Do we really get anything out of it? Is anybody doing anything with the training? And if the energy training is right and it's targeted right, it is very effective. And for the end user, they're the ones that have to go through and you guys have to convince your boss. How do I go through and do the training? And the boss is going to say, okay, is it worth it? Do we want to spend the money? What are we going to get out of this? So I want to talk just a little bit about training, and I'm going to concentrate on compressed air training, and in particular compressed air challenge, since I teach both the fundamentals and advanced, and it's been a proven one. So it does solve problems. There's multiple layers of training, as you can see on the right-hand side. We have it for the plant people, for fundamentals and advanced. We have system specialists with the qualified Airmaster, and then we have end user operator awareness training. And of course, there's the best practices manual, which is a one-stop source for all of the best practices for compressed air and going through and implementing it. So again, it's about educating, and it is effective. It is a product neutral portfolio, and this is a study that the Department of Energy did, saying that 76% of the end users actually did changes in their site based on the material and what they learned. The ones that implemented it, they implemented 149 megawatt hours, roughly 7.5% of the energy savings prior to the class. And when you look at it from a cost yield, which you do for going through and saying, is it really cost benefit? The ratio of $82 per every training dollar spent on actual implementation. So, and since 1999, when Compressed Air Challenge was formed, we've trained over 20,000 air users. And so again, it's very, very important, and the mission still continues. And a little more recently, we worked with a couple of the utilities that put on training just to say, hey, can we let's go back and look and see if there's an idea of what we can find. So a couple examples of it was Focus on Energy and Efficiency Vermont. So for Focus on Energy, they went back 6 months afterwards. They contacted were able to get a hold of 3 of the attendees from 3 different companies. They went through and put in 6 projects, each one doing 1 project. You can see the range there of the actual kilowatt savings. The total savings for the program was 355,000 kW, and the value to the program was 53,000. For Efficiency Vermont, this one didn't have, the attendance was a little lower because of a snowstorm we were in, but they did still have some attendees be able to come in, and a couple of their customers reported out. A paper company was able to go through and reduce their air usage by going through and attacking a lot of the inappropriate uses and air leaks that we talk about. And they went from 450 CFM to 375, saving over 98,000 kilowatt hours. And a cheese company, it reinforced the importance of finishing the leak correction project, and it saved them over 53,000. So again, the program value was 23,000 for them at the 15 cents a kilowatt hour. One that we really did a concentrated effort was Amerin, Illinois. So between September 18th and July 19th, they really leveraged the compressed air challenge training they were doing with their utility outreach that they were doing. So they did 3 fundamentals, and really it was targeted at 270 facilities in Illinois within 100 miles of the training sites. And prior to each event, they'd send email blasts out, and their people would reach out to a lot of their key customers up to 3 times. The training captured the audience of 57 attendees with out of 47 facilities, so there was great response with it. The training was immediately followed up with a thank you email, and the local advisors then followed up within 2 to 3 weeks to see if they could help with their key accounts on any of the things. So the actual results were outstanding. So the direct impact they had 25 applications from the registrants, actually getting 6.4 million kilowatt hours into the program, which was a value of 320,000. And then the indirect impact for all of that marketing and outreach they did, they saw that during that time that they were doing the compressed air challenge training and going through and doing this outreach, the applications in their programs over the entire program pieces of it and the actual kilowatt hours almost doubled during that time. So again, it did a great job with making people aware not only about the class, but about the programs they had. And so it was a huge savings that they had over of $1 million that they would have. Again, this was over and above from what they had when they weren't running the actual class. So why is it effective? It is action oriented, and that's what I really want to get into now is the best practices, the systems approach. Too often you go through and look at compressed air, and everybody's looking at compressed air as, geez, it's a training that's it's a system, and it's air compressors. And as a powerhouse chief, the pipe went through the wall, and that was the end of it. If you don't go out and see what's there, you don't know where the savings is, because again, it's a supply and demand. I always said if they don't make it, if they don't use it, I don't have to make it. And that's a real big thing. So systems approach is important. An action-oriented approach is also important. This just is for those of you that may have taken fundamentals in advance, it's combined the 7 and 8 step plan. But the whole point of this is it's going out into the floor, finding out what the opportunities are, establishing a baseline, making sure you go through and do the walk through the system to understand what's happening out there, identify the issues that are out there, go through and make a plan to correct them, and then go through and communicate it, and then look at and implement an awareness and continuous improvement program. So the CAC's approach based on those pieces, again, you're looking at awareness training, establishing a baseline, aligning the supply and demand and controls. Again, that's really important. Demand strategy, maintenance, design, publishing savings, and then employee awareness with the continual improvement, and then also integrating it into any system that you have. So I've got the ones that are in blue due to sake of time and 20 minutes. These are the ones that I'm going to concentrate on just at a high level, but I'll be more than happy to answer any other questions on any of these at the end of this thing. So baselining, really you want to go through and if you establish a baseline, because you got to go through and know where you started to know whether you actually made improvements or not. So you want to establish it using flow and power consumption, either measured or calculated. You want to go through and do the leak load, understand what your leaks are in a facility, develop a pressure profile for the system dynamics. So how much drop is there? What do you have through the system? How quickly does it react, and how dynamic is it? You want to convert that compressed air usage to dollars. And then of course, the cost per widget is very, very powerful. It puts it on terms that everybody can understand. So typical components of demand, you have your production, you have leaks, you have the inappropriate uses, and then you have this excessive demand due to excessive system pressure known as artificial demand. And we'll go over a little bit about what that is. So really the demands drive what you have to produce. So you want to go through and have a real good demand strategy. So you want to attack these inappropriate uses, the leaks. You want to go through and work on the artificial demand. And then you want to look at the end uses so you can go through and take advantage to reduce system pressure. So first, inappropriate uses. What do we mean by that? Well, many times over the years, you've gone through and used compressed air over time, the technology's gotten better, so we want to go through and look at where we're using compressed air. This is an example to show if I was using a 1 horsepower motor versus a air motor versus an electric motor. This could be on a mixer, it could be on any type of a piece of equipment. But at 5 days, 2 shift operation, that costs $2,300 versus $390 on the compressed air. So you can see it's very costly. So we want to look at where we can go through and make these conversions. This is just a list of the inappropriate uses. I'm not going to go over all of these. We again go over them in the training, but I'll concentrate and just give one example on the open blowing that you really want to look at. But these are all prevalent in the plant. One of the ones that is very prevalent is open blowing. This can be anything from just copper nozzles to actual regular nozzles to air knives. It's used to blow off material, dust, dry. It's used to do a lot. Really, you want to look at going through and getting a blower system or engineered nozzles to be able to, and knives to be able to go through and do this. Some of the inappropriate uses that I corrected when I was at Ford, we went and switched over the paint mixers to electric, DC tools to get rid of the pneumatic tools, air blowing in the paint shop and part drying. We went to high efficiency nozzles or if we could, low pressure electric blowers, and or high pressure blowers if we really needed it. I should say high volume blowers. And then of course, personal cooling, cabinet cooling, and then vacuum generation on like part movement in the stamping plant where you have vortex cups. We would go through and put engineered cups or smart pumps. So again, there's other things you can go out there and do that are much more cost effective. Air leaks is a huge one. Department of Energy says that even a tight system will have a 10% leak, and it's common to find 20 to 30%. And kind of a did you know, 10 cents a kilowatt hour, a $200 leak can be felt but not heard. An $800 leak can be felt but not heard. And then a $1,400 leak can be felt and heard. So if you're in a plant hearing it, it's at least $1,400. And again, it's very costly. So this just gives you a size of what the cost of it is, and the actual air leaks that's there. That should be the 1/4 inch. I did a metric presentation, so I apologize. But that bottom is a 1/4 inch for over 16,000, almost $17,000. And air leaks, you're going to find them prevalent all over. They're in many different forms, anything from handheld ones to equipment that's leaking to repairs that aren't done right, and even to the one in the middle there where you don't need an ultrasonic leak detector to know that's leaking. You can see it on the wall. And then blowdowns that are on tanks. So leaks are prevalent throughout the system, and it's a real big waste that you really need to work on. So how do you do that? You implement an aggressive air leak program that finds and fixes leaks. So really, you're going to go through, it's an ongoing process. You're going to go through and estimate the leaks when you do it. You use ultrasonic leak detection. Most important thing is you find them and fix them, publish the results to management, and then go through and make it as part of your awareness and continual improvement program. System pressure reduction. We talked about a little bit about artificial demand. We want to go through and reduce system pressure. And to do this, we need to really look at the air quality requirements, high pressure applications, and then high volume intermittent applications. These are all things that can drive up your pressure and require you to have higher pressure. So for a 2 PSI decrease, 1% efficiency, it's a rule of thumb. So 100 horsepower running at 80 rather than 100, that's going to save you $6,500 per year. So if you can go through and get the ability to reduce pressure, you've got a really great opportunity there. Woodhaven stamping is just an example. Done all of these things: leak detection, pressure drops were reduced at the plant. They got rid of some high pressure assumptions. Satellite air compressors were removed. They reduced it by 18%, shutting off an 800 horsepower compressor, eliminating 300 30 horsepower booster compressors, reducing the system pressure by 5%. Excuse me, saving 7.9 million kilowatt hours and 400,000. And just kind of the last, don't forget that last dirty 30. That's the last 30 feet of pipe. And that seems to be the biggest problem you have in the facility where all of the errors occur and the problems occur in the system, from pressure drops to leaks. And maintenance, just a bit about that. Supply side, demand side, you really need to keep that up. It's often a necessary evil and one of the first places that budgets get cut, and it is penny wise and dollar foolish. This just gives you some examples of pressure drops across filters and dryers. Again, 2 psi equals 1% efficiency if you're going through and increasing it. Moisture through the dryers, it's got loading, it's got qualities, it shortens the life. And then dirty inlet filters. For every 4 inches of water, it's 1% efficiency. And of course, the top one is production downtime. When I was the powerhouse chief at Chicago, we had huge downtime with the compressors. And until I got it under control, you got to put in a maintenance system just to take care of it. And then, of course, as a global energy manager, I didn't use much energy, so it was really about the people that did. So people use compressed air, you really want to get them involved. So if I told you you could reduce compressed air energy by buying jackets, hats, keychains, pizza, would you buy it? Well, that's exactly what the Monroe stamping plant did. They had an hourly energy team. They got red jackets so they'd stand out. They implemented an aggressive energy awareness and air leak program. So they gave away buttons, keychains, hats, t-shirts for reporting and getting leaks fixed, and pizza lunches for the best red coat energy audit for shutdown on the weekends. They posted leak boards throughout the plant, used the Ford communication network for messages in each of the break rooms. The result, they went from 17.4 million cubic feet to 9 million cubic feet. The non-production usage really dropped from 5,400 to 600 CFM, and the electricity savings was over $200,000 a day. And more importantly, it created a real culture of awareness in the plant. Key components on awareness, you want to target the operators, use site examples, overview of the compressor, understand the demands, make sure that the people know that it's inefficient and very expensive and that they're the key to saving it. CAC operator training, I'm just not going to go through a lot of this, but it is a training that's there. It's meant to be like a toolbox talk, 30 to 45 minutes, flexible. You go through and put all of the plant stuff in there. It can be done by plant personnel, instructors, so it's very flexible. But the real key is it gets to the people that use it and makes them aware that they're the most important. It's very expensive. They really need to look at the type of uses and that they're the key to going through and making the difference in it and using this expensive utility wisely. And then additional things that are included in it are definitions, pictures from the supply side, demand side, and then who to contact for help at the end of it. And the final thought for energy efficiency, make it part of what you do, not additional. Integrate into the processes you have. If you have strategic energy management, ISO 50001, ISO 14000, sustainability initiatives, lean manufacturing, plant facility goals and objectives, all the stuff in blue is what we did at Ford. Again, you want to go through and make it part of what people do, so it's not an additional task. And then just for additional information, you can go to the Compressed Air Challenge website. KGI also has now certifications and the fundamentals and advanced are for the actual body of knowledge for the specialists that's there. So that's an opportunity if you want as well. Here's my contact information. And with that, I'll go to questions and turn it back over to Frederic.
Yeah, thanks, Joe. Thanks everyone again for coming. And if you have any questions, please drop them in the chat now. We'll take your questions. Joe, I just wanted to, if you could expand on that project that you had at Ford with the red shirts and that kind of culture shift. Did that take? What was the timeline on that? Was it a year that you started to see results? Was it within months? Like how long did the culture change need to take hold?
Uh, they actually started getting results within the first couple of months. And the one thing I'll say that it's always good to do is when you start something like that, and you can get management on board and say, yep, we're going to do something about it. If you tell them what the cost of everything is and go in with it, it was funny because it was an hourly led UAW team, and the leader of it, Jack, he was a kind of a bull in the china shop, which was good because he would go through and if people weren't doing what they needed to be doing or getting things fixed that didn't need to get fixed, he would let them know about it. So they started building momentum pretty quick, and I would say within a year's time, the culture changed pretty rapidly. That they went through and had too. So it was really an important step that they took, and they started going through and taking on as they were able to build success. They were able to take on more and more into the thing, including taking on large press repairs for the old tandem presses that they had.
Great. Yeah, we had a couple questions come in. So thank you for sending those in. Feel free to keep on sending them in. First one is where's the best place to start in reviewing a system?
That's a very good question. The best place to start, if you saw the back to the action plan, probably the best place just to quickly start is to draw a block diagram of the system. Nothing fancy. It's not any kind of uh, architectural drawing. It's just simple square boxes and circles and everything you'd have on a flow. Step back and start looking at what your system is. So start with the compressors and then take it into the plant to do it. Once you go through and start looking at it, one thing I found out over the years is compressed air systems are always engineered. The problem is then they grow and they're in plants, things change, production changes, and as plant people, we just get things done. We make sure production runs, we make sure we do whatever needs to be done to get things, make sure we're continuing to produce parts. So you need to go through and just do it. So we go through and put it in where it needs to be put in, put stuff in, take it out, just whatever we need to do it. The problem is over time, you may not have that, you may not have put the system in properly, and it may be actually hurting you either with too much pressure drops. It might be hurting you with putting in dry air into a wet system. There's a lot of different things that can happen, and it's not anybody's fault other than the fact that we took a compressor out, we put a new one in. Well, you may have taken out an old oil compressor, put in an oil free with a heated compression dryer, and then dumped it back into a wet system that goes to a non-cycling dryer. That happened to be one of the systems that I walked through with a client I had. And they didn't even think about it because they just took one compressor out and put one compressor in. So I would start there. And then definitely once you've done that is, yeah, make sure your controls are set. You've got a baseline. That's an important part to establish that. And then start going out in the plant and start looking at what's out there and what you have. Because again, if you've got to get out there in the demands, because you can go through and have the most efficient compressor system, do all the maintenance, do everything right. But if you've got 50% air leaks in the plant, then you're just wasting your time because you can be as efficient as you want, but it's just going to cost you a ton of money. So that's what I would suggest. Again, that kind of following the processes that we have for the 7 and 8 step processes is really a good walkthrough on how to go through and look at a plant facility.
Great, thank you. One other question that's kind of a admin question. It's from Ian. I see this is being recorded. Can I get a link to watch the recorded webinar? Of course, we will have the webinar up on our website, so mielnergyconference.com. I typically get it up in the afternoon, same day of the conference or same day as the webinar. So feel free to go there, and I'll send you a link, Ian, as well once we get that published. But yes, all of our webinars are online. If you just go to the register section up at the top of your screen, you'll be able to get to where the presentations are in general. So with that, I think we're going to wrap it up. Thank you again, Joe. If you go to the next slide, we'll talk about our next presentation. We have process and HVAC controls. That's going to be on December 1st. We're going to give everyone a week off for Thanksgiving. So we'll see you again back in December. Again, thank you for attending today. Thank you, Joe, for a great presentation. And I hope everyone has a good and safe Thanksgiving. So yeah, thanks again for coming.